Choose the correct letter that will make the following statement true. The formula to calculate the volume of a pool B is pi times 5 times height. So the middle part there, they're not giving us the name. So let's go back to pool B. Before we finish off, let's go to pool B. Pool B is a cylindrical shape. So the volume there would be, we've given the pi times radius squared. So I'm already seeing, even though they've given me the number there, they didn't give me squared. And also the radius there is not 5. That's the diameter. See? So no, that's not the one. And then we have one that says pi times 2,5 squared. Now we have the squared times height. So this one is, the pi is correct, the height is correct. Let's just double check. The diameter here is 5 meters. If we divide 5 meters by 2, we get the radius. But what is that? 2,5? That's correct. Is it squared? This is actually the correct one. This one is wrong because it says here 5. 5 is not the radius because the formula says times radius. 5 is the diameter, making this one wrong. Right? So the answer here is B. 3.5. 3.5 says pool B is estimated to hold 65,000 liters of water. Determine the depth of pool B and round off your answer to 2 decimal places. I'm not going to worry about rounding off because that's just the answer. So first I'm going to worry about what they want me to calculate. So they're saying pool B, which one is pool B? This one, which is circular. And they are saying determine the depth of pool B. So what are they asking us to calculate? What is a depth? Depth is when you're there. How deep is the pool? You can say it's the height of the pool, but it's actually called the depth because you're going down and not up, right? You're looking, if you were to stand at the top of the pool, how deep would be from top to bottom, right? So what we want to know is how deep. So what is happening is they're not asking us the volume, they're asking us the height. But if you go to the formula of the volume, it says volume of a cylinder is equal to pi times radius times height. So we can use this formula to calculate height, right? As long as we have the volume and we have radius, we can calculate the height using this formula. Now let's come back here. If you check in the question, it says there's something they tell you first. It holds 65,000 liters. This is the capacity. Now remember, capacity can be changed to what? To volume. So if they give you capacity, you can have volume. So let's first do that. 3.5. I'm going to say 3.5, I'm going to say pool B, I'm going to change 65,000 liters and I'm going to change it to meter cubed, right? And how can I do that? By using the conversion factor. Let's look at the conversion factor. There it is, right there. 1 cubic meter is equal to 1,000 liters. So I'm going to use that. 1 cubic meter is equal to 1,000 liters. Then there's an is equal to there. And then we're changing liters. Which side is written liter on? It's on the right hand side. So we have 65,000 liters instead of 1,000, right? And we don't know what is the cubic meters of this. But what we do know is if we cross multiply, we'll get it. So 1 times 65,000 is equal to unknown times 1,000, right? And 1. So we go and look for unknown. Unknown is this side and it's multiplying by 1,000. We don't want it to sit with 1,000. So what is the opposite of multiply? It's divide by 1,000. That goes away. And then 1,000 dividing this side as well, we get the answer. So our unknown is equal to 65,000 divided by 1,000 is equal to 65 cubic meters. Now we have the volume. right? We just changed 65,000 to cubic meters using the conversion factor. That's all we did. And then now, what did the question ask us to calculate? Don't make a mistake just because you're using this formula now you're going to calculate volume. What did the question ask us to calculate? The question said, calculate the depth, determine the depth of the pool. The depth would be the deepness of the pool, which is the height from the top to the bottom of the pool. Well, the bottom to the top of the pool. And then for me, I'd say that on this formula, that's the height. So that's going to be my unknown. Do not substitute anything there. You don't have it. But what do I have? I have a volume, which was given to me as 65,000 liters. And I said, I can't use that. I changed it to cubic meters. And then I said that 65 cubic meters. And then pi is 3,142 multiplied by the radius. So what is the radius? It's 5 meters divided by 2, which gives me 2,5 meters. That's what the radius is. So that's 2,5 meters. Now I have a problem. Something is squared here. This part is actually squared. Then I multiplied by height. Let me write the full thing like that, right? Okay, so these two are numbers. So let me sort them out first. But first, this is squared. So what I'm going to say is I'm just going to write everything else and come straight to this part, which is multiplied by, and then I say 2,5 squared. 2,5, because my calculator is this, I'm going to say times 2,5. That gives me squared. That's 6,25 meters squared multiplied by height. Remember, height was still unknown, right? And then I can multiply these two numbers now. Okay, so I'm going to go ahead and leave 65 cubic meters again there because I want to know what these two numbers are. If I multiply them together, it's 3,142 multiplied by 6,25, and I get 19,6375 meters squared. And then I multiply that by height. Remember, nothing's happened to height yet. Then I say, okay, fine. Now, this number is sitting with height. Height is our unknown. We need to move this number that side. It's easier to move once you've fixed it out into one number. So let's move it to the other side. Say height is unknown. It's multiplying by this number. So what we do is we just divide, because the opposite of multiply is divide. So we'll divide by 19,6375 meters squared. And guess what? Boop, boop, right? So when we do this side, we divide it by 19,6375 meters squared. And now it appears on the other side. So now I'm just going to take my calculator and say 65 divided by 19,6375. And I get my answer, which is 3,309993635 meters is equal to height, right? Round off your answer to 2 decimal places. Okay, whatever. 3,3. This is 2 decimal place. I'm just going to check the next number there. It says zero must become 1. All right, meters is equal to height, and we're done with 3.5. 6. Pool B is filled with water at a rate of 1.5 cubic meters per minute. Ooh. Hence, Mrs. Palati claims that it can be filled to 92% of its capacity by 8, which is in the morning, if the filling process starts at 7:30. Verify whether Mrs. Palati's claim is correct. So they start at 7:30, they finish at 8, and they should by then have filled 92%, says Mrs. Palati. Pool B, okay, how much water is actually in Pool B? 65,000 of water. And how much is 92% of that? I want to first know that. Let's first calculate that. So that's 3.6. It's the easy part. Finding out how much 92% is. In Pool B, there is 65,000 liters of water, right? In Pool B, there's 65,000 liters of water. So what we're going to do is we're going to find out how much water is she saying is in there. She's saying after at 8 a.m. there will be let's calculate. 65,000 times 95 divided by 100 will be 61,750 liters. There. That's the number of liters she's saying by 8 will be there. Then she says, if you start at 7:30 and end at 8, right? But how long is that? I'm going to calculate first. How long is that, right? So what I want to do is, because why am I calculating how long that is? And why am I calculating the number of liters she's talking about? That's because here she's saying 1,5 cubic meters per minute, right? Okay. So now I know that for 1 minute, there's 1,5 cubic meters. What I'm going to do is I'm going to change this to liters so that it compares with this. So I said 92% of its capacity, right? Capacity is liters. Remember, I said capacity is liters. If they say volume is 65 liters, they're actually saying capacity is 55,000 liters, but you can change it to volume, right? Okay, so what we're doing here is we say find out how much water is in there, and then we went and said, okay, so I want to find out per minute how much water is going in there. What I'm going to do is I'm going to use the conversion factor and say, wait, so the next part is that I'm going to find out how long it takes to put in the 92% of the water, and that would be, I'm going to say 800 minus the finishing time minus the starting time, 7:30. How do I minus that? Okay, 0 minus 0 is 0. Now, if I try, say 0 minus 3, that's not going to work. So what I'm going to do is I'm going to go to the hours. This is minutes. I'm going to go to the hours, and I'm going to go to this 8 and borrow 1. What is left? 7. Right? And then I'm going to come back to the minutes. I've borrowed 1 hour. The moment I cross to minutes, 1 hour becomes what? 60 minutes. Right? So now I have 6 plus 0 is 6 minus 3 is 3. Ah, magic. And then 7 minus 7 is 0. So it actually took 30 minutes to put in this water that she's saying went in there. Okay. Now, we have one more step. We have two choices. We can change the liters to cubic meters so that it fits this and we can use it, 1,5 cubic meters per minute, or we can change the 1,5 cubic meters to liters. I want to be fancy. I want to change the 1,5. Okay, so I'm going to change the 1,5 this time. Next time I do this question, I promise I'll change the other one. Okay, so let's say 1,5. So again, how do I convert that? Using the conversion factor, 1 cubic meter is equal to 1,000 liters. Right? 1,5 cubic meters is equal to unknown, and I cross multiply. 1 cubic meter multiplied by unknown is equal to 1,5 cubic meters multiplied by 1,000 liters, and then divide by 1 cubic meter this side, divide by 1 cubic meter that side, and then yeah, calculator, 1,500 liters. So 1,5 cubic meters is 1,000, which means that 1,500 liters is poured in 1 minute. Right, 1,5 cubic meters is poured in 1 minute. Per minute means 1 minute. 1,5 cubic meters is poured per minute. 1,500 liters per minute. Now, if I want to use it, I'll write it this way, right? Okay, now let's use it. This is 1. Let's use it. She said, remember when we did our calculation, she said 95% of the water in the tank. And then we said, how much is 95% of the water? And that is 61,750. Okay, now let's find out. How long will it take to pour We don't know the time, but we have water, 61,750 liters. We don't know how long it will take. We're going to calculate that so that we can check if she's correct when she says the 30 minutes will be enough. So calculate then. And then we say it's 1,500 liters multiplied by unknown is equal to 61,750 liters multiplied by 1 minute. And then what divide by 1,500 liters, and you do the same that side, and you use a calculator. 61,750 times 1 minute divided by 1,500 gives me 41,6666667 minutes. So not correct. You're supposed to say that, sorry, she's not correct. 3.8. When Mrs. Palazzi wanted to swim in her pool, the temperature of the water was 19 degrees Celsius, and she said she would only swim if the temperature of the water was 25 degrees Celsius. The temperature must increase by 6 degrees. Calculate what the temperature change would be in Fahrenheit. You know, after all of that, all they wanted us to do was the increase here is actually the change. So it went from, she says it must change from 19 to 25. But changed by what? By 6. Increased by 6. And they're just saying, just calculate the temperature of the change, which is 6 degrees.